Welcome to the second course in the blockchain specialization titled Smart Contract. This course is completely dedicated to smart contract, the computational element of the blockchain technology. Let's begin with the origins of a smart contract. In the first course of the specialization, Blockchain Basics, we discussed how proven algorithms and techniques for encryption, hashing, and peer-to-peer networks have been creatively applied to the innovation of blockchain, a decentralized, trusted, distributed, immutable ledger. The concept of the smart contract was there well before the advent of the Bitcoin. Computer scientist Nick Szabo detailed his idea of cryptocurrency Bitgold as a sort of a precursor for Bitcoin. He also outlined the concept of smart contract in his 1996 publication. In fact, Szabo coined the term smart contract more than 20 years ago. Smart contract is the centerpiece and main thrust of Ethereum blockchain. It is the good, bad, and the ugly of the blockchain technology. It's a powerful feature. Improper design and coding of a smart contract resulted in significant failures such as DAO hack and parity wallet lockup. It is such a dominant feature of blockchain, which is why we've devoted the second course of this specialization to help you design, code, deploy, and execute a smart contract. As we discussed in Course 1, Bitcoin has a script feature that includes rules and policies. Linux Foundation's Hyperledger blockchain has a smart contract feature called chain code. The chain code is written in Go language and executed in a Docker environment. Docker is a lightweight container technology for executing programs. You can find more about these in the resource section. Many variations of smart contracts are prevalent in the blockchain context. We've chosen to discuss Ethereum implementation of smart contracts since Ethereum is a general mainstream blockchain and it has been used as a reference blockchain for many others. At the end of this course, you will be able to explain the elements of a smart contract, discuss the syntax and semantics of a smart contract programming language Solidity, solve a problem and design a smart contract solution, use Remix development environment for building and testing smart contracts, and deploy the smart contract using Remix and invoke the contract from a simple web interface. In this course, it is imperative that you try the various concepts related to smart contract in a test environment in order to understand and apply these concepts. We'll use Remix Integrated Development Environment IDE, which is a web interface for hands-on explorations. At this time, please make sure you're able to access this interface at remix.ethereum.org. Be warned that Remix is only a development environment and it keeps changing as new features are being added even as frequently as weekly. This course is one in which you will experiment with smart contract. Then in the next course, we'll develop complete end-to-end applications using a smart contract. On completion of this module, you will be able to explain the elements of a smart contract and explain the types of problems a smart contract can solve. Define the structure of a smart contract. Apply this knowledge to understand with a real smart contract written in Solidity language. Use a web development environment Remix to invoke and interact with a smart contract. As we begin, let's remember Bitcoin blockchain is primarily meant for transferring digital currency. Bitcoin added a simple conditional transfer of value through an embedded script. Recall from the Blockchain Basics course, Course 1, that this is a conditional feature that was bootstrapped as a soft fork in Bitcoin. The script was limited in its capabilities. It enabled simple conditional transfers. After Bitcoin, evolved Ethereum. The founders of Ethereum developed smart contract keeping Nick Szabo's idea of a smart contract from over 20 years ago in mind. A significant contribution of Ethereum is a working smart contract layer that supports any arbitrary code execution over the blockchain. Smart contract allows for user-defined operations of arbitrary complexity. This feature enhances the capability of Ethereum blockchain to be a powerful, decentralized computing system. Why would you want to transfer currency? Cryptocurrencies such as Bitcoin enable transfer of value such as money or currency from peer-to-peer without any intermediaries. For what? To give somebody, to buy a product, maybe even renew driver's license or send flowers to someone? Let us elaborate further. We may want the gift to be delivered on a certain date. Buy a product of a particular color and quality. We may need some credentials verified for renewing the license. And we may need a specific tulip bouquet to be delivered to Buffalo. This introduces conditions, rules, policies beyond that of which a simple money transfer cryptocurrency protocols can handle. Smart contract addresses this need for application-specific validation for blockchain applications. Smart contract has some advantages, including a smart contract facilitates transaction for transfer of assets other than value or cryptocurrency. A smart contract allows specification of rules for an operation on the blockchain. It facilitates implementation of policies for transfer of assets in a decentralized network. It also adds programmability and intelligence to the blockchain. The smart contract represents a business logic layer with the actual logic coded in a special high-level language. A smart contract embeds function that can be invoked by messages that are like function calls. These messages and the input parameters for a single message are specified in a transaction. Let us compare Bitcoin transaction and a smart contract transaction. As you can see, in Bitcoin, all the transactions are about send value. In the case of a blockchain that supports a smart contract, a transaction could embed a function implemented by a smart contract. Here we have a voting smart contract. The functions are validate voter, vote, count, declare winner. Smart contract provides a layer of computational logic that can be executed on the blockchain, thus availing the features enabled by the blockchain framework. Recall the layers of a decentralized application that we discussed in Course 1, Module 2. Observe the smart contract providing the application framework for a domain application. For example, consider home mortgage application. Smart contract could embed all the business logic and the intelligence for the rules and regulation to allow for automatic computation and initiation of operations. How might this be different from existing systems, you may ask? Here, all the operations are transparent and are recorded on the blockchain. Customers can directly access the tools without an intermediary like a bank. It is like the ATM for mortgage initiation. You are holding the assets instead of an intermediary. Now that we have reviewed the advantages of a smart contract, let's look at what problem or problems a smart contract can solve. Typically, currency transfer is used to buy a service, a product, or a utility from a person or a business. There may be other conditions besides availability of funds for executing a transaction. For example, a business transaction may involve rules, policies, laws, regulation, and governing context. Smart contract allows for these other real-world constraints to be realized on a blockchain. Thus, a smart contract enables a wide variety of decentralized application of arbitrary complexity to be implemented on the blockchain. This can run the spectrum from supply chains to disaster recovery. It is likely many of the applications for the blockchain technology have not yet been conceived. It is predicted that online shopping will overtake retail shopping for the first time this holiday season, 2017-2018. Some couldn't have even imagined online shopping, mobile application, or Uber 20 years ago. Smart contract is assuring the next generation blockchain that goes beyond the transfer of value into a visionary realm. Smart contract allows for implementation of rules, policies, and with the help of blockchain, supports the methods for governance and provenance. Next, in the upcoming lessons, we'll explore how to design and implement a smart contract.